Okay, this question to do with straight line graphs to finish the paper. Reading through, we spot that there's going to be perpendicularity involved, and that speaks gradient, doesn't it, to us? So we're going to need to know the gradient of line L to begin with. So before we fully understand the root of the solution, let's just quickly work out the gradient of line L. Tell the examiner what you're doing. So I've moved the minus 6x, add 6x to both sides rather, divide by 4, and there we have the gradient is 6 over 4. So I'm just going to write that down and make sure that the examiner's clear that I understand that the line L has gradient 3 over 2. Okay, next step. Line M then has gradient minus 2 over 3 because it's perpendicular. And remember, if the gradient's a fraction, just flip it over and times it by minus 1, and that gives you the new gradient for a perpendicular line. Great. Right, you've got two options now. You've got a method 1 and a method 2, which I'm going to go through. Method 2 is far more efficient and recommended, but I saw a lot of candidates doing method 1, so I will show you that one as well. Just to be clear, I think method 2 is much better, and you'll see in a moment why. So line M, if we know it has gradient minus 2 over 3, we can write down a template for that line. We then know two things about that line. We know it passes through this point 5, 6, and also this point minus 4k. So using the 5, 6 point first, we can work out the value of c by substituting that in and rearranging. And just trust me on that, that gives you 28 over 3 as the value of c. Let's rewrite our equation for the line, but with our known value of c now. And this time we're going to substitute the other point, minus 4k, in. Rearrange that, and we get k is 12, which is the correct answer. But check this out, this is much more efficient. Method 2. So still the same working all the way up to this point here, but then just notice that we don't actually need the equation of line M. We only need to deal with its gradient. So we have a formula for gradient, don't we? Change in y over change in x. So that we can do k minus 6 for our change in y, and minus 4 take away 5 for our change in x. And that should just be equal to minus 2/3. So you can straight away write down that equation. The gradient that we know is equal to this way of working out the gradient. The denominator is minus 9 on the right, times both sides by minus 9, and then add 6, and there's k equals 12 much more easily.